Okay, so I'm going to pick a couple of these slides to walk you through my thought process on how to do these, and then hopefully you'll be okay. Come to office hours if this is confusing to you. Okay, so we have 1, 2, looks like 3 roots here, so I'm guessing this is a degree 3 polynomial. If I zoom out a little bit, I can see, yep, the arms are going, one arm is going up, one arm is going down. Now notice the left arm is up and the right arm is down. So as I'm going toward positive infinity over here, so on this side, the positive infinity side for x, my y values are falling down here to negative infinity. So this means we have a negative a value. So I'm going to start just by dropping in my negative a value there. Then I know that I have a root here at negative 12. So it's going to be x plus 12. And then, oops, messed up my parentheses. Then I have a root here at, oh, not there. That one, no. Let's see. Let's zoom back in a little bit so I can actually find my root. Negative 2, so that's an x plus 2. And then my last root is at 9, so that's an x minus, oops, there we go, x minus 9. And there we have matched our function. So pay attention to which arm is up, which arm is down. On odd degree polynomials or on even degree polynomials, are both arms up or both arms down to determine if you're going to have a positive or negative a value. And then we'll go here. Okay, so this one seems pretty straightforward. I think you guys got it. I want to find one like this, actually. Okay, so notice right here, there's a root at 0, and actually it's a bounce point. It's a double root. So when I come down from here and then I hit the axis or the origin, in this case here 0, and then I pop right back up. So this is a degree, or this is a 0 and it's a double root. So what does that mean? And okay, let's also talk about our a value. These arms are facing down. So I'm going to do negative first because I know it's facing down, so I need a negative a value. And then I'm going to say x squared, because what we have here is this double root where it's bouncing off the origin like that. So that takes care of that one. Then we also need to take care of our roots over here. So I click on my blue line again because I've already started. I can actually click on the root. So I have a negative 5, 0. So that'll be an x plus 5 as my root. And then over here, my other one is at 7. So that'd be an x minus 7 when I write it in factored. Oops, don't forget the x minus 7. And there we go. We've matched our quadratic. Okay, let's see if we can find one or two more. Oh, this one looks fun. Okay, so we have a root right here at negative 6, and it looks to be a double root because I go up, bounce off the axis, and come right back down. So this would be like a negative x squared parabola. So it's got a vertex on the root and then goes down. But in this case, it's just part of the parabola. So then we go up, 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 and down. And this is also a double root because it comes down, bounces off the axis, and goes back up. So this has 1, 2, 3 roots that I can see, but notice 2 of them are double roots. So this is actually a degree 5 polynomial. So we're going to have 5 different roots, but 2 of them are doubled up, so that makes our lives a little easier. It looks like we're starting low. So as x goes toward negative infinity on this side of the axis over here, as x goes toward negative infinity, y is also going toward negative infinity. And on this side, as x goes toward positive infinity, y also goes toward positive infinity. So this is a positive degree, so we don't need to worry about our a value there, just positive. So we know we have a double root at, looks like maybe negative 6 here. Yep. So x plus 6 squared. And then we are going to multiply that by, let me fix my notation here. Let's see, what was our next one? We had negative 1, so that's going to be x plus 1. That one is not a double root, so it's just going to stay like that. And then our last one, our last bounce point over here is also a double, so that's going to be x minus 8 squared. Double it up because it is a bounce point or a double root. Okay, so that takes care of our 1, 2. So we get 2 roots from here, 3, 4, 5 different zeros. So this is a degree 5 polynomial. Okay, there's one last one I wanted to show you. Let's see if I can find it. Here it is. Okay, so this one's slightly trickier. I gave you a hint, so maybe you figured it out on your own. If not, no worries. This is a challenging idea. But basically, if you look right here at this -4 root and you trace the function down, that section of this function looks just like our cubic functions. Remember when we looked at cubic functions beginning of the year and we had one arm up, one arm down, and it kind of turns at that locator point? This looks like a cubic function. So that root right there is actually being cubed. So just like the last couple we talked about where we had those double roots, this one is actually a cubic. So this is going to be x plus 4 to the power of 3, cubing it. Okay, and then we also need to take care of this guy over here. So this is an x minus 6. And there we have it. There is our function. That one's a little bit tricky though. Yeah, so give the rest of these your best shot and come to office hours if you have questions. Hopefully this is making some sense and these videos are helping. Miss you guys.